Alright, we can start it. In the following few weeks, we will learn about circular motion. For circular motion, I think we started on one of the seminar, but let's solve an example. We have a body that moves in a circle. For every motion, we need, next to the units and so on, we need a coordinate system. The coordinate system is a straight line. I usually use a horizontal line, and which said this is the theta equals 0 and this is the origin. You know, this is like polar coordinate system. In 2D means you with r and not y, but in this case with theta, you can give the position of any of the 2D object. But the circular motion is a special case because look, the r is a constant. That means we have to worry only how the angular displacement depends on time. The rest is very similar. If you derive the angular velocity, you will get the angular. If you derive the angular displacement, you will get the angular velocity, and if you derive it again, you can have the angular acceleration. Beta, in some textbook, it can be alpha. Two other things which is important: the period time, which is the time you need, for example, starting at the theta equals 0 to go back in the same position. And the frequency 1 over t, so this is by formula 2 pi over omega, is the frequency. The theta has no unit, the omega is 1 over s, alpha or beta is 1 over s square, time is t, and the frequency is 1 over s, but by conversion we use the hertz. Alright, let's solve an example. Let's start with the constant angular velocity. Origin, theta equals 0, and let's say t equals 0 second I'm here, t equals 1 second I'm here, 2 second here, 3 second here. So this is the time, theta, t equals 0 second, I'm at pi over 2, 1 second, pi, 2 second, 3 pi over 2, and 3 second, this is 2 pi. Please give me how the angular displacement depends on time and write the result in the Discord. Omega equal constant. I wait 3 minutes to solve that. Alright, then let's solve it together. Let's create a graph. Can have us 0, 1, 2 and 3 seconds, and this is pi, 2 pi. At 0 I'm here, at 1 I'm here, at 2 I'm here, and at 3 I'm here. So this is a straight line that was expected from the constant angular acceleration. The straight line has two parameters, a times t plus b. How can we find what is the b? B is technically here. The theta at t equals 0, so it should end with plus p over 2. And what is the slope of this straight line? If you go 1 unit left, you go up pi over 2. So that will be pi over 2 times t plus pi over 2. Let's check it. For example, theta t equal 2 equal pi over 2 times 2 plus pi over 2, which is 3 pi over 2, and that's exactly what we have here. Alright, so that's how you should solve it. You can connect to the smart cup. One of you have already connected, and you can download these table screens. Now it's high time you to solve something. Let's say at t equals 5, I'm here. At t equals 0 second, I'm at the origin. T equals 10 second, t equals 15 second, and at t equals 20 second, I'm back to the origin. The theta equals 0. So please tell me what is the theta t. You can draw. Now I wait again 3 minutes. Thanks, that's okay. It's pi over 10 times t. Since at t equals 0 we were at 0, so there is no p, so there is no offset part. And let's just double check it. So for example, at t equals 10 I'm at pi, which is exactly where I am. Thanks for the answer. Let's go further. Perhaps not yet that example at first. Now you can imagine what is theta t. Theta t is the time dependence of the theta. It can be anything, not only a straight line. It can be, for example, p over 2t squared plus pt minus 2 pi. Draw a circle and tell me where on this circle is the body at t equals 0. So it's pi over 2 0 square plus pi times 0 minus 2 pi. What's this minus 2 pi? So this is where I start. This is the positive direction. This is theta equals 0. This is the positive direction, means I have to move in the negative direction 2 pi, but technically it's still in the original position in the theta equals 0. Alright, can you tell me where is the body at, for example, 2 seconds? Now I'm waiting 1 minute. Alright, so pi over 2 times 2 square plus pi times 2 minus 2 pi. This is 2 pi, this is 2 pi, and this is of course minus 2 pi, which is plus 2 pi. That means from the theta t equals 0, I moved 1 round and came back in the same position, so I'm still here. Alright, thanks. What is the omega t? Omega t is a derivation of the angular displacement. That's pi t plus pi. So for example, at t equals 0, this body has an angular velocity pi. What does it mean? So this pi means every second